Hello, I'm Rebecca the Maths Lady and welcome to this video which is all about formulae or formulas. It really doesn't matter, you can say either. In this video I'm going to be emphasising the importance of children deeply exploring the context of any formula that they work with at this age. I'll take you through the 4 steps that they need to go through to develop that deep understanding of the formula they're working with, and then we'll talk about how they solve, and then we'll talk about the 2 types of problems they'll have to solve once they've got the hang of the formula they're working with. There is no skip link here because this is the last video in this series about number age 9 to 11, but I'll be back soon with the series about applied maths age 7 to 11 where we'll be covering shape, space, measure and data. This is the 3rd in a series of 3 videos about algebra, and it's really wise to watch the first 2 before you watch this one. So here's a link to the first of them, which is about algebraic notation, and that'll lead you on into the second, which is about missing number problems, and bring you back to this video. Right, let's get started. So the key to working on formulae with this age group is to really deeply explore the context of each formula you ask children to work with. And it's useful to think about doing that in 6 steps. First of all, you want to develop a table of inputs and results about the situation. Then you want to describe what's going on in words and use that description to predict results that aren't on your table. Then you want to create a formula that's written in words. Then you want to write that same formula in algebra. Then you want to use the formula to predict results. And finally, you want to work out inputs from results using the formula. So let's have a look at what that might mean in practice. Imagine children are exploring the lengths of toy trains, where the train has an engine and some carriages. So for example, the length of the engine of a toy train might be 7 centimetres and a carriage might be 10 centimetres long. So a single carriage train will be 17 centimetres long. How long would a 2 carriage train be? Well, we can build it and quickly see that that will be 27 centimetres long, and so on. So we can talk about that situation, we can let children play with the moving parts, and then we can start to build a table of results, which could look something like this: number of carriages and length. So if we've got 1 carriage, that was 17 centimetres long. With 2 carriages, it was 27 centimetres long. With 3 carriages, you'd have 3 carriages that are 10 centimetres each, and the engine of 7 centimetres, so that would be 37 centimetres, and so on. So step 1 is to create a table of inputs, which is the number of carriages in this case, and results, which is the length of the train with that many carriages. Step 2 is to talk about what's going on, and a really powerful way to do that is to say, well, if we had a train with 10 carriages, how long would it be and why? And the children need to express their reasoning. Well, we'd have 10 carriages of 10 centimetres each, so that'd be 100 centimetres, and the engine, so it'd be 107 centimetres. And they're beginning to have a sense that you need to multiply the number of carriages by 10 and add 7. So step 3 would be to clearly write down that relationship in words, to find the length of a train, multiply the number of carriages by 10 and add 7. Then step 4 would be to write that as an equation. You can choose whichever letters suit you, but in this case it might be L equals 10C plus 7. And I'll get children to talk to each other to make sure that everyone deeply understands what's going on there. So we can use this formula, L equals 10C plus 7, to find the length of a train with 20 carriages or 12 carriages or 7 carriages. Children can work on questions like that. They know they just need to multiply the number of carriages by 10 and add 7. And then finally, step 6 is where you set children the kind of problem where you tell them the length of the train. Say it's 137 centimetres and they have to puzzle out the number of carriages. In the first type of problem, we were evaluating this expression. In the second type, we're solving a missing number problem. So we're saying, was it 137 equals 10c plus 7? Find c. We've got 137 here. What is the number of carriages? And you can do that with a block diagram, and we explained that in the last video. Here's a link to it now. Yes, you'll have some children who can just make sense of formulae really quickly, but a lot of children can't, and this is how we go through the steps as a class, which mean not only that every child is understanding what's going on, but also that the children who find it really easy are challenged to think visually and flexibly and communicate with children who can't necessarily understand their thinking easily, and that is a very powerful thing for them to do. There are lots of simple problems we could work on. We could think about tables in a cafe. If every table is square and every table seats 4 people, we could develop a formula for the link between the number of tables and the number of people you can have in the restaurant. It's just a nice single step formula where you're multiplying the number of tables by 4 to find the maximum number of people. But you could adjust this. If you had to put the tables side by side, so when you had 2 tables, you'd get 6 people. And when you had 3 tables, there'd be 8 people. It's really interesting to explore the formula for the number of people you can have when there are different numbers of tables. You can build a table, you can make predictions for large numbers of tables, you can explore and explain how you got your prediction, then you can write the formula in words, and of course the number of people is double the number of tables, add 2 for the people at the end. Then you can write that as a formula, and you can work out numbers of people for different numbers of tables, and you can work out numbers of tables for different numbers of people. Another situation which translates easily into an appropriate formula would be buying objects online, where you're just buying one type of thing and you're buying a certain number of them and you have to pay a delivery charge. So, for example, if it was a box of cat food and a box of cat food cost £4 and there was a delivery charge of £2, you can start to develop a table of results, make predictions, explain what's going on for the charge, and work through all the steps that I've just described. In the next series, I'll be doing a lot of work on shape, and that offers lots of beautiful opportunities to develop formulae. For example, if you're looking at the perimeter of a rectangle, if you do lots of work where you give children the length and the width, and they have to puzzle it out slowly, gradually, they will start to see that they can do it quickly by doubling the width and doubling the length. So you can express that in words. The perimeter is double the length, add double the width. Or in algebra, P equals 2L add 2W. But not all children see it that way. Some children see this length of 15 and double it. So they would be saying that the perimeter is double the length, add the width. And of course later on in maths they'll come to easily understand that these expressions are the same, but it's nice to touch on it now and reassure them that they are, and that they'll come to understand that better in the future. And we can carry on and give children L and W and ask them to find P. And we could give them a perimeter and ask them to find lengths and widths that would give them that perimeter. And again, we covered finding pairs of variables in the last video. Similarly, you could look at the area of a rectangle equals LW, length times width. And there are lots of formulae that you come across. With each one, you want to spend lots of time puzzling with the situation, letting children work on plenty of examples, and work on them until they can express the relationship in words, write it down, and then contract it to a formula so they deeply understand where that formula has come from, why it exists, and what it means. It's just a shorthand way of writing a long sentence. The extension work for this topic? Well, one of my favourites is to get children to puzzle out a formula for the surface area of a cuboid if you're working in the context of shape. But really, you can push them to develop their own formulae for any situation. Let them be creative. What interests them? Where have they come across formulae? Get them to teach you and the class about a formula that makes sense to them. So your takeaways from this video are that there are 6 steps for working with formulae. And if you think through these 6 steps, they really help you dive deeply into the context of each particular formula. And it's essential children learn to do that. If they are ever presented with formulae where they haven't worked on the context, perhaps in a test or an exam, you need to teach them that they have to spend time unravelling what that formula means and making sure they can clearly imagine in their head what's going on before they start work on the question. I showed you some examples of some formulae that it'd be appropriate to work on, and I mentioned that you come across quite a few formulae in the applied maths that we're going to cover next series that it's really suitable to use and explore as you work on this topic. Well done if you've watched the whole of series 3, number aged 9 to 11. That's awesome. You're going to be a fantastic teacher. You should be so proud of yourself. Thank you for taking the time to take this journey and become a fantastic primary maths teacher so that we can have a generation of kids who deeply understand maths. I'll be back soon with series 4 on applied maths aged 7 to 11, where we'll be covering shape, position, measure and data. I'm hoping to get that finished by the end of 2020, and then I've got a little bit of infill work to do on year 2, aged 6 to 7. I'll do overview videos for each year and publish some resources for planning in 2021. All being well, stay safe, look after yourself. Bye for now.